That's an excellent question. I will tell our audience at home. It's kind of weird for me to say that because there's no audience at home because we're filming now. And this is not Saturday Night Live, although some days I feel that my class is like Saturday Night Live. But the question is, can you wait until the end to put this negative sign next to the heat lost, which is this? And the answer is yes. You can calculate heat gained, calculate heat lost, and then plug into the final equation and take the additive inverse of whatever you put in for heat lost. Dan, does that make sense to what I just said? Okay. All right. So what I did was, I just wrote everything out. You'll see that it's heat gained equals the additive inverse of the heat lost. I wrote out the equations for the heat gained, and that's going to be the mass of the ice times the change in temperature, final minus initial. So it'll be 0 minus, what was the initial temperature of the ice? Do you remember?
-30.
So it'll be 0 minus a -30 times the specific heat capacity of ice, right? Plus 3 terms, 3 transitions, 3 terms. And then it would be, just a second, hold your question. It'll be the mass of the ice times the heat of fusion. And then the third transition will be the mass of the ice times the change in temperature. What temperature is the final temperature? 20 degrees? 20 degrees Celsius. So it'll be 20 degrees Celsius minus 0. Notice that each of the 3 terms for the heat loss, for the heat gained, the 3 terms for the heat gained are positive. That's big. Why? Because look at it from the perspective of the ice. It's gaining heat. It's endothermic. So it's positive. Judine, you had a question?
Is that 20 or 30?
I don't know. What did I say?
You said 30.
It said 20.
Oh.
It would be -30 and a positive 20. Isn't that what I said?
Yeah.
Okay? You all right with that? You're not all right with
You
that?
can go on.
I can go on. Thank you. I appreciate that. All right. A little confusion there with the introductory data that I put on the board. Now, the heat gained, the heat lost is the mass of the steam. And it would be 100 minus, what was the initial temperature of the steam? 150, so it would be 100 minus 150 times the specific heat capacity of the steam. So that term is going to be negative because 100 minus 150, that will make the entire term negative, which makes sense because the steam is giving up heat. It's endothermic. It's reducing the internal energy, so it's endothermic, so it's negative. That should make sense. The mass of the steam times the heat of vaporization. There's nothing mathematical that makes that negative, such as here, where the negative sign is put into the term mathematically, correct? Just by manipulating the data. This you have to actually put in. You have to understand that it's a release of heat of vaporization, so it's going to be negative. So you have to artificially put in that it's negative, correct? I think I showed that on ice problem 2, part 2. So if you want to look back at that, if you haven't seen that already. And then the mass of the steam. Initial is 100 liquid, down to 20 liquid, right? So it'll be 20 minus 100, that's also negative. So that term's negative, 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 which makes sense because, again, it's exothermic, correct? End of subsection B. You all right with that? Mm-hmm. Jason, you look absolutely positively enthralled by this whole activity. It's amazing, really. I haven't seen you this interested ever. Excellent. Excellent. He's very interested. Okay, excellent.